Hello everyone, how are you all? I hope you all are doing very good. In today's class, we are going to study how to draw the ray diagrams of the image formation by convex lens when the object is placed at infinity in front of convex lens, when the object is placed beyond 2f1, when the object is placed at 2f1, when the object is placed between 2f1 and f1, when the object is placed at f1, when the object is placed at f1, and when the object is placed between optical center and f1. These are the 6 cases of image formation by convex lens. These all things we will study, and we also study how to form the image by a concave lens when the object is placed at infinity, and when the object is placed between infinity and optical center in front of a concave lens. And we also will try to take the image characteristics of each case, and will prove that the image characteristics which are given in the textbooks are originally can be derived by drawing the ray diagrams. With the measurements we are going to draw the ray diagrams, and we are going to learn perfectly drawing of ray diagrams of lenses. Okay, before going to learn those, you should be having some rules are there. There are some rules to draw the ray diagrams. What are those rules? Those rules are, when you have a convex lens and when light ray comes parallel to principal axis, like this, the incident light ray is coming parallel to principal axis, how the refracted light ray will go. And one more rule is there, when light ray passes through focus of a convex lens, how the refracted light ray will pass. When the light ray passes through optical center of the convex lens, how the refracted light ray will pass. These 3 rules we should be knowing in case of convex lens and in case of concave lens. Then only we can draw the ray diagrams perfectly. Okay. So now let us learn these rules first. So when light ray comes parallel to principal axis, first what happens, observe neatly. Here on this surface one refraction will happen. First surface, this will be the first surface, correct? This will be the first surface and this one will be the second surface, correct? So on the first surface refraction will happen and it will bend towards the normal and it will come in this direction. And on the second surface again refraction will happen and again it will bend. After bending, if we apply the angles or the Snell's law of refraction using the angles, which is the angle formed here, we will automatically get the refracted light ray will be passing through the focus on the other side of the lens. Okay, that's how we are going to get the refracted light ray passing through focus of the other side. So here what happens, here one refraction will happen, here one more refraction will happen. But we are not going to represent those 2 refractions here. In between at the center we have taken a straight line, correct? We are going to take the incident light ray until that straight line. Okay. So after that, from that straight line only, how the refracted light ray will go, we are going to draw. This one will be the refracted light ray. Okay. So this is incident light ray and this one will be the refracted light ray. Actually what happens, here's one refraction and here one refraction will happen. But commonly we are taking one point or one surface where the refracted light ray will bend, because we have only thin lens in our syllabus. Okay. So when light ray passes parallel to principal axis, or when incident light ray passes parallel to principal axis, the refracted light ray will pass through focus. Okay. Now what happens when light ray passes parallel to principal axis in case of a concave lens? When light ray passes parallel to principal axis in case of a concave lens, the refracted light ray will appear to be passing through the focus of the same side. Why? Because concave lens will be a diverging lens, correct? So as concave lens is diverging lens, the refracted light ray will be passing like this. Okay, na? Next, what is the next point? When light ray, next case is when light ray passes through focus. See, when light ray passes through focus of a convex lens, what happens? Incident light ray passes through focus. What happens to the refracted light ray? The refracted light ray will pass parallel to principal axis like this. Like this. This is in case of a convex lens. What is the case in case of a concave lens? See, now will the light ray pass through focus like this? See, like this? No. The incident light ray should appear that it is passing through the focus. See, we have taken the second side focus and incident light ray is coming like this. Okay, now the refracted light ray will pass parallel to principal axis like this. Like this. Okay, this is how the refracted light ray will go when light ray passes or appears passing through focus. This light ray is appearing that it is passing through focus. So the refracted light ray will pass parallel to principal axis. And the last case is when light ray passes through the optical center. This question is also one of the important question in the board examination. When light ray passes through the optical center, it will not go through any deviation. It will pass straight. No refraction will happen. Why? Because when light ray passes through the optical center, it will be passing perpendicular, means like this. When there is a glass slab, if you remember, if there is a glass slab, if the light ray passes like this, what happens? The light ray will not go through any deviation. It will pass straight. Like this, there will be a small part of the lens which will be working as a glass slab, and the incident light ray, when it passes through optical center, it will be passing like this at the center of the lens. So it will not go through any deviation. It will pass straight. So these three rules should be there in your mind to understand the image formation of convex lens and concave lens. Now let us take one after the other, one case after the other case. Then we will draw the image formation with the measurements. With the measurements, we are going to draw the ray diagrams. Okay. So first ray diagram is object placed at infinity in front of a convex lens. Correct? Right. So now let us, first step to draw this ray diagrams is take a straight line of length 12 centimeters. See, first diagram I will draw with the measurements perfectly, and next all you should be able to redraw it. See, first I am going to take a straight line of 12 centimeters. See, 12 centimeters, and I will mark points at 3 centimeters, 6 centimeters, 9 centimeters, and 12 centimeters, and 0 also. Okay na? So now remove this point scale. This point is going to be our optical center. This point is going to be our focus 1, and this point is going to be our 2f2. Sorry, 2f1. This point is going to be our f2, and this point is going to be our 2f2. Now we have to construct a lens now. Correct? How to construct lens now? Take a compass and take the radius as 6.2 centimeters. Okay? See, you can verify. I am taking the radius as 6.2 centimeters. See, 6.2 centimeters. Now take 2f2 as center and draw an arc like this. Okay. Afterwards, change the center to 2f1 and you complete the arc like this. You got the lens now. Yes or no? Very easy. The extra things you can erase. Now you draw a straight line passing through the optical center. This is the optical center, and you draw the straight line now. Now where is the object placed? Object is placed at infinity. Correct? Object at infinity. When the object is at infinity, how the light rays should come? light rays should come with starting with dotted lines, correct? So object is at infinity and light rays are coming from the object, so they are going to start with the dotted lines and they will continue with straight, right? So here if you observe, these two light rays are coming parallel to principal axis. When the light rays comes parallel to principal axis, after refraction, how they have to pass? They have to pass through the focus, correct? So now this refracted light ray will pass through focus like this. And here also, this refracted light ray also, it will pass through the focus. These two are the refracted light rays and these two are the incident light rays. The point where the refracted light rays will meet, we call it as an image. So image is formed where? At F2, correct? So now let us write the image characteristics. Okay, image characteristics. What are the image characteristics? Image is real and all real images will be inverted images, correct? Where is the image formed? Image is formed at F2. And what is the height of the image? Height of the image is highly diminished. Highly diminished. When we get the height of the image at least some extent from the principal axis, then we can say it as diminished. But now here we got it is a point, correct? So this is going to be characteristics of image formed by convex lens when the object is placed at infinity in front of a convex lens. So at infinity over, correct? So at infinity over, what will next position? Next position when we take the object closer to lens, next position will be behind 2f2, 2f1, correct? So now next diagram is object placed beyond 2f1. You can verify. I have taken a straight line already of 12 centimeters. See, 12 centimeters and 3 centimeters, 6 centimeters, 9 centimeters, 12 centimeters. I marked points and I marked the points as f1 to f1 and f2 to f2 and taking 2f1 as center. Taking 2f1 as center, I drew one arc, and taking 2f2 as center, I drew another arc and I got the lens. Now object is placed beyond 2f1, correct? Now you just extend this principal axis, okay? Now after extending it, just take an object. How much shall we take the object? Take the object height as, see, from here to here, how much is there? It is around 2 centimeters, correct? Take the object height as 1.5 centimeters because it should fit within the lens, right? So you can verify. I am taking the object height as 1.5. See, 1.5. Okay, na? 1.5 centimeters. Now this is the object. This is the point where light rays will start, correct? So here we have to take two light rays. One light ray I will take parallel to principal axis. Okay, na? So parallel to principal axis, one light ray I will take. Correct. After refraction, how it should pass? This is the incident light ray, and after refraction it should pass through the focus like this. Okay, clear. One more light ray we want. Which light ray shall we take? We can take one more light ray through focus like this, and after refraction it will pass parallel to principal axis. Or else you can take directly one more light ray through optical center like this. Okay, now? Now let us take the next light ray through optical center like this. Through optical center. See, this is the incident, this is the point, right? Through optical center like this, let us take. Just extend it. See, where did the two refracted light rays meet? Refracted light rays met here. So the point where the refracted light rays will meet, that point we call as image. This is image, correct? So this one will be the image. Now measure the height of the image. How much we got? You can verify. It is not even 1 centimeter. Correct? Not even 1 centimeter. So what can we say about the characteristics of image formed by the convex lens when the object is placed beyond 2f1? So image characteristics. How the image is? Image is real. Correct? And all the images, all the real images will be inverted images. So image is real and inverted. Where is the image formed? This is f2 and this is 2f2. Somewhere in between f2 and 2f2 image is formed. Correct? So image is formed between f2 and 2f2. Between f2 and 2f2. Correct? And what about the height of the image? Height of the image we verified, right? We verified height of the image was 1 centimeter. You can verify here. Height of the image is not even 1 centimeter and height of the object is exactly 1.5 centimeter. So height of image is lesser than the height of the object. Correct? So image will be a diminished image. Image will be a diminished image because height of image is less than the height of the object. Correct? Right. Next, after this we will place object still closer and object will be placed at 2f1. Correct? So next case will be object placed at 2f1. See, object placed at 2f1. Here we are going to place object exactly at 2f1. How much shall we take height of the object? Height of the object also will take as 1.5 centimeter only. Exactly at 2f1, 1.5 centimeters. You can see this one will be the object O. Now from this object we are going to take one light ray parallel to principal axis like this. Okay. After refraction, how the refracted light ray should pass? The refracted light ray should pass through the focus like this. Correct? Another light ray, how shall we take? Another light ray I will take through focus. Okay? See, through focus I am taking. Another light ray through focus I am taking. Okay? See, exactly passing through the focus. Right? So this is another incident light ray. When incident light ray passes through focus, the refracted light ray should pass parallel to principal axis. Correct? I will take light ray parallel to principal axis through focus. Right? So now if you look at, this will be the refracted light ray. So this is the image. Correct? This is the image. Now if you look, this image is exactly formed below the 2f2. Correct? We measure the height of the image now. Height of the image, see how much it is? 1.5 centimeters. Measure the height of the object now. See, height of the object is also exactly 1.5 centimeters. This one will be the image and this one will be the object. We got height of image is equal to height of the object and image is real and inverted formed at 2f2. So now let us write the image characteristics. Image, it is real and inverted, and where is it formed? It is formed exactly at 2f2. Formed at 2f2 and equal size image. There is no magnification, there is no diminishment. Equal size image is formed at 2f2. Correct? So this is about the image formation of the object placed at 2f1. Okay na? Now next where shall we place? Next we will place object between 2f1 and f1. Correct? So now let us take the next case. Object placed between 2f1 and f1. Right? So now here let us take an object here between 2f1 and f1 here. Height of object, we'll take it as 1.5 centimeters. You can see in front of you only I am drawing. This is the object O. One light ray, let us take parallel to principal axis. Okay. One light ray I will take parallel to principal axis, and after refraction how it should go? It should pass through the focus. This is the focus and this is the point, right? So, and one more precaution is, all instruments you should be having very sharp and you should be precise in drawing. Then only you will get the images perfectly, or else you are not going to get the images perfectly. Okay. So let us take one more light ray. How shall we take one more light ray? Through optical center we can take, or through focus also we can take. We can take through optical center. If we take through optical center, this is the optical center point and this is the object point. So these two we have to join, right? Where they both got met. See, this is the point of intersection. So this will be the height of the image. This is the height of image. Measure the height of image. How much it is? It is 2.5 centimeters, right? You can see height of image is 2.5 centimeters. And what is the height of object here? Height of object is only 1.5 centimeter. Am I correct? So this is how we are going to get the magnified image in case of a convex lens when the object is placed between 2f1 and f1. So now let us write the image characteristics. Image is real and inverted. Why it is real? Why? Because the refracted light rays, both refracted light rays are originally meeting. We are not imagining. Correct? And formed. Where is image formed? Formed beyond 2f2. And the image is magnified. Because height of image is greater than height of the object. Correct? Right. So next let us place the object at f1. Now let us take the object at f1. Object is placed at f1 now. 1.5 centimeters. Okay. 1.5 centimeters object is placed at f1. This one will be the object. Now take one light ray parallel to principal axis. See, right, one light ray parallel to principal axis. After refraction, how it should go? It should pass through the focus. Like this, it is passing through the focus. One more light ray we can take through optical center. See, this is the optical center and this is the object. Correct? This is the optical center and this one will be the object. These 2 points should coincide on the scale now. Right? See, now these two are parallel to each other. When the two refracted light rays are parallel to each other, where they will meet, we imagine that they are going to meet at infinity. Correct? So they are going to meet at infinity. Where they meet, that is only the image for us. Correct? So image will be formed at infinity. Image will be formed at infinity. So now let us write the image characteristics. Are they going to meet? Yes. So image will be real and inverted. And where image is formed? Image is formed at infinity. Whatever the magnification of image will be highly magnified. Highly magnified. Okay. Now last case of convex lens, and very important case and very careful case. Object placed between optical center and f1. This ray diagram, we have to be careful while drawing this ray diagram. Why? Because it will take so much time if you don't know and if you don't take the precautions to be taken. Okay, what are the precautions to be taken? The precaution is object should be within this range, optical center to f1, from here to here, right? Take a point, midpoint of optical center and f1. Somewhere here you take the object. If you take object here, what happens? You will not get the image, or you may not get the image within the page. As you take the object closer to optical center, image will form within the page. You take it as a homework and you can try it on your own. Take object here, close to focus f1, then draw the image formation. You will not get easily. But if you take object here 1.5 centimeters, take object here somewhere here, then you will get image for image nicely within the paper. This is the object. Now to form image we need two light rays. One light ray passing parallel to principal axis like this, and after refraction how it should pass? It should pass through the focus like this. One more light ray we shall take through optical center. Okay, na? Through optical center. Now if you look at these two refracted light rays, this is one refracted light ray and this is another refracted light ray. Are they going to meet anywhere? They will never meet anywhere. Why? Because those two are diverging light rays. Diverging light rays will never meet anywhere. That's why what we are going to do, we are going to extend the refracted light rays back side. See, like this, we are going to extend the refracted light rays. This is only refracted light ray, correct? Refracted light ray is extended back. Okay, now one refracted light ray and this is another refracted light ray, correct? So like this we got the image formation here only. See, this point will be the image, correct? This is the image now. Measure the height of the image now. Height of the image, how much we got? Again 2.5, 2.4 centimeters. Correct? So, image is magnified image. Is the image inverted now? No, image is not inverted. Image is erect. Is the image real image now? Image is not real image now. Image is virtual image. Why virtual image? Because we are going to extend the light rays back. We did not do any modification. We did some modification for the refracted light rays and we made them meet, made them intersect. That's why image will be virtual and erect. And where is image formed? Image is formed on same side of lens. Correct? Where the object is placed, on the same side of the lens, image is also formed. And what about the magnification? Image is magnified image. Because height of image is greater than height of the object. Correct? Right. So I hope you understood how to draw the ray diagrams of image formation by convex lens in all cases. Now let us go to the image formation by concave lens. Okay. First I am going to explain to you how to draw lens first of all. How to construct a lens first of all. Afterwards, constructing the lens, I will explain to you how to draw the image formation. So here, first step is to take a straight line of length 12 centimeters here also, from here to here, 12 centimeters, and mark points at 3 centimeters, 6 centimeters, and 9 centimeters. 12, 0. This is going to be our optical center. This is going to be our F2, this is going to be our 2F2, and this point is going to be our F1, this point is going to be our 2F1. Now you take a compass and take the radius of compass as 5.8 centimeters. 5.8. Don't take 6.2 now. For convex lens we have to take 6.2. For concave lens we have to take 5.8. If you take radius as 5.8 centimeters, 5.8, 5.5, yes, 5.8 centimeters, and draw an arc here. And take 2f1 as center once again and draw one more arc here. Now you close the arc like this. Now we got the concave lens, and from optical center you draw a line like this. Why is this line required? Because this line is the line where we are going to take the bending of the refracted light rays. Correct? So now this is the concave lens we got. Now where is the object placed now? Object is placed at infinity. When the object is placed at infinity, how the light rays will come? Light rays will come starting from dotted lines. Correct? First object at infinity. Object at infinity. There is meaning for everything we draw in the ray diagrams. Correct? So here we are starting with dotted lines. Means the object is placed at infinity. One light ray is coming like this, and one more light ray I am going to take below the principal axis. Like this. This is the two incident light rays coming from the object. So now in concave lens, after refraction, how they have to pass? They have to pass, or they have to appear that they are passing through the focus. Correct? Like this. Like this. Now this is one light ray and this is another light ray. So now these two refracted light rays, are they meeting anywhere? They will not meet at any point in front, but we can imagine that they are starting from this point. Means they have met at this point. The point where the refracted light rays meet, that is only our image I. Correct? So now this is only our image now. Let us try to take the image characteristics. Is the image real? No, image is not real. Image is virtual, and all virtual images will be erect images. Virtual and erect. Right? So now next, where is the image formed? Image is formed at f1. Image is formed at f1. What is the height of the image here? Height of the image is negligible. So we say the image is highly diminished. Image is highly diminished. Okay. Now next, one more case is there in case of a concave lens. Here in this case, wherever we want to place the object, we can place the object. Concave lens, object placed between optical center and infinity. In between optical center and infinity, wherever you want, we can place the object. Image characteristics will be same characteristics we are going to get. That's why I will place object. Where shall we place? We can place anywhere. I will place the object here, and I will take the object height as 1.5 centimeters. Why am I mentioning object height now? Why? Because we have to measure image height also now. This is object. And now let us take one light ray from object parallel to principal axis. Okay, one light ray parallel to principal axis. After refraction, how it should pass? It should pass through the focus, or it should appear like diverging from the focus. Correct? Like this. Now one more light ray. Let us take through optical center like this. Observe neatly this diagram. One light ray passing through the optical center, incident light ray now over. Correct? Now this is the incident light ray. Correct? Now when light ray passes through optical center, how the refracted light ray will pass? The refracted light ray will also pass straight like this. Correct? Now This is one refracted light ray, this is another refracted light ray. Where these two are going to meet, they are not going to meet anywhere. That's why I am going to extend this light ray back. And this light ray, refracted light ray, which is started from the optical center, this light ray also I will extend back. So I am extending, see now, I am extending back, dotted lines I am drawing. But those dotted lines are present upon this line only. That's why you will not be able to see that dotted extension. Right? So now this light ray is also extended back, this light ray is also extended back, and they both met at this point. Correct? This one will be the image. Correct? So image characteristics, let us write. First find the image height. How much is the image height now? It is approximately 0.5 centimeters. Okay. So image height is lesser than the object height. So image will be diminished image. Correct. Let us try to write the image characteristics. Image is virtual and erect, and image is diminished image, and where is image is formed? Image is formed between optical center and F1. Between optical center and F1. Okay. Now I have a doubt. You know that wherever we want to place the object, we can place. Image will be formed between optical center and F1 only. Correct? Image will be formed between optical center and F1 only. If I place the object itself here, are you getting my point? If I place the object itself between optical center and F1, where the image will be formed? Can anyone answer? Sorry. So let us take the object itself between optical center and F1. Object between optical center and F1. Object between optical center and F1. Where the image will be formed? First let us construct the ray diagram first. Take a straight line of 12 centimeters. Mark the points at 0 centimeters, 3 centimeters, 6 centimeters, 9 centimeters and 12 centimeters. Okay. This is optical center, and this is F2, and this is 2F2. This one will be F1 and this one will be 2F1. Taking 2F1 as center, one arc, and taking 2F2 as center, one more arc. Okay. Close the arcs now. Using a scale, you can close the arc. And draw the perpendicular line. Now what is my question? Take the object itself between optical center and F1. Here, take the object only. Where the image will be formed? Image will be formed between optical center and object. In between here, image will be formed. If you place object anywhere until the focus, until here, wherever you want to place the object, image will be formed between optical center and focus F1. But if you place the object itself between optical center and F1, image will be formed between optical center and the object. Let us draw now. Let us construct the ray diagram. Let us take one light ray parallel to principal axis. After refraction, it will pass through focus. Pass through focus. One more light ray through optical center, like this. So this is the point where image will be formed, correct? So this is the image. Image characteristics did not change, virtual, erect and diminished, but image has formed between object and the optical center. Okay, so this is about the ray diagrams, how to draw with measurements perfectly of lenses. Thank you so much. We'll study more in the next class. Thank you so much. Keep learning. All the best.